All right, let's shoot a rocket. All right, so rocket from right here. Okay, so then from here the rocket goes this way. Okay, so you shot. Okay, so now the speed was, all right, let's see. Ooh, very fast. Okay, 200 meters per second velocity. That's initial velocity. Then, the question is how far this gonna fly. Then actually we are looking for x. Okay. Then wait a minute. Then x value is the distance actually. Distance. You remember that rate times time. Rate here velocity. But what kind of velocity? Horizontal velocity. So we're gonna use vx. Okay. So times how long this gonna take. That's it. Time. Very simple. See? That means we're gonna find out velocity for x. Okay, not this slant. Okay. So let's find it. Okay, I made a right triangle right there. Okay. So yeah, that's right. That was a 60 degrees, right? Okay. This rocket shot 60 degrees from the ground. Okay, so 60 degrees. Remember that. Okay, that means that's right. So you know 60 degree triangle means 1, 2 square root 3 ratio. But you still can use this. The base, in this case, base is what? Cosine. Remember that one. Okay, cosine 60. What about the height right here? It's a sine 60. Oh man, very simple. So that means, wait a minute. Okay, so from this origin to this point is a 200. Okay, 200 now. Okay, this is cosine 60. What's cosine 60? That's a half. Oh, that means a half of that one, which is, so that means 200 times cosine 60, which is half of that one, which is 100. Wow, this one right here, Bx is 100. Oh man, so now all we have to find out the time. Time, we're going to use this one, okay? So how long this going to be in the air? That's it. Okay, that means simply we're going to find out T1, T2. You know why? Because you remember that? Okay, so all the way up, that's time 1, I think, okay? Then what about time 2? Yeah, that's it. But in this case of time going up, time for going up, time for coming back, exactly the same time. That's why T1 equals T2. Okay, it's like that. So that means if we find out T1, so we have to multiply by 2, so we're going to get T. Okay, that's it. All right, let's find it. Okay, all we need T right here for time. How? Wait a minute. In there, we need the time. So what kind of rule do you have to use then? Oh man, that's right. We gotta use this one right here. Okay, so you know why? Because final velocity right here. See this one going up, 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 all the way up. Then finally, it's gonna stop. I'm talking about upward, downward. Okay, so this one keep going sideways, but not upward, right? 0. That's why this Vy gonna be 0. Okay, so actually we're gonna use this one. This is the velocity, final velocity. Okay, so equals initial velocity plus, but this one's going up, but you're gonna use g, right? Okay, but this one's a negative g. Okay, so then it's a negative 9.8 times t. So we're gonna find out the t. But you know the final velocity is 0. Alright, 0. Now, initial velocity for vertical is this one times 200. Oh, wait a minute. Okay, sine 60 means what? That's right, square root 3 over 2. That means 200 times square root 3 over 2. That means 100 times square root 3. Okay, 100 times, that means, okay, what do you think about square root 3? That means square root 3, you know that already, but 1.7321. So 100 times that one, that means you just put point right there. Hey, you gotta know that one, okay? That means this velocity, initial velocity for vertical initial velocity is 173.21 minus 9.8 t. Now we're gonna find out t. That's it. We're talking about actually t1 right here. Okay. Then later you just multiply by 2. So we found t1 is 17.67 about. Okay, so round up. Okay. So now t equals twice of that one, so about 35.34 seconds. Okay, then we just plug this one in. Okay, that's it. 35.34. See how easy it is? So you just multiply 100 on that one, so about 3,534 liters. Okay, so that means about this is about what? Okay, 3.534 kilometers. Wow, man, that's right. This rocket can fly this far, about more than 3.5 kilometers. Oh man.